So now we're gonna continue the remaining part in this chapter, in this revision part. You know it from last year. Three theorem. I'm sorry. Sorry. Okay. Theorem in a right triangle, the median relative to the hypotenuse is half the length of the hypotenuse. I saw some of you they wrote this on their copy because you saw it on the video. But you need to be careful. M is the midpoint. Here, M is the midpoint of BC. What does it mean? It means that I can give you AM, for example, here 4. I can tell you if AM is 4, calculate BC. So what will be BC in this case? 8. Or the inverse, I can tell you BC is, for example, 6. What will be AM? 3. So I can give you a question two ways. I can tell you if AM, for example, if AM is equal to 4, directly you can deduce if M is the midpoint, what do we call AM? AM will be the median relative to the hypotenuse, not any median. And you cannot do the median from B to AC, no. Doesn't work. M is the midpoint of the hypotenuse. So if AM is 4, BC will be what? 8. I can give you also opposite. I can give you the hypotenuse and I'll tell you deduce AM. So if, for example, this one here, I'll change the color. If I gave you, for example, BC6, what will be AM in this case? If BC is 6, AM will be what? 3. So if BC is 6, what will be AM? I can deduce AM is equal to 3. This property is very important. You will use it later. So just put in your mind, in a right triangle, if I have the median drawn from the vertex to the midpoint of the hypotenuse is all the time equal to half of the hypotenuse. Now I have the inverse of this property, like we have Pythagoras and inverse of Pythagoras. The inverse of this property is if a median in a triangle, any triangle, has a length that is half the length of the side to which it's drawn to, then the triangle must be a right triangle. You cannot say it's half to the hypotenuse, half to the side drawn to. What does it mean? I'll give you an example. For example, I can draw this triangle here like this. I can give you the measurements. I can tell you this is 2, for example, and this is 5. Is it a right triangle? Is ABC a right triangle? No. Why no, it's not a right triangle? Because the median is not equal to half of the side drawn to. Look, 2 is not half of 5. But here, I can give you another triangle. If I draw this one here, it's another triangle. Okay, and I will give you, for example, this one. Let's take this one 5 and this one 10. And I'm gonna tell you, is this triangle a right triangle? Yes. Why? Because the median, for example, I can name this median AM, is equal to half of CB. The median is equal, listen to me, to half of the side drawn to, not half of the hypotenuse, because it's not yet a right triangle. When it's a right triangle, I can work or I can use the word hypotenuse. So in this figure here, it's not the right triangle because the median is not equal to half of the side drawn to. In this one, yes. So what does it mean? How many methods you have to prove a right triangle? Sure, we have the famous method. If I have a 90-degree angle, this is one of the method to prove right triangle. If I have a 90-degree angle, I can prove a right triangle. If I have the three sides given, what should I use to prove if it's a right triangle? I can use the inverse of Pythagoras. So inverse of Pythagoras helps me to find if it's a right triangle. And if I have a median and the side drawn to the measurements given, I can use the inverse of the median to check if it's a right triangle. So how many methods we have? We have 3 methods. We have the 90-degree angle, we have inverse of Pythagoras, and we have the inverse of the median to prove a right triangle. Now let's go to a very important part. Special right triangle. This is very important, very important, very important. Special right triangle. What does it mean, special right triangles? What are special triangles? We have a scalene triangle. This is not a special triangle. We have right triangle. It's a special triangle. We have isosceles triangle, we have equilateral triangle, but you have special right triangles. It means right isosceles triangle, one of the special, and we have another one. We're gonna see first the right isosceles triangle. Right isosceles triangle. How you know that it's right isosceles? So we have this size 45, 45, 90. So if you see here in my figure, I have this is a right isosceles triangle. How you know that it's right isosceles? Because here is 90 and here is 45. So what will be this angle 45? So directly I can prove that it's isosceles, right isosceles, because it has 90 degree and 2 equal. And when you have a special right triangle, you don't need to have all the measurements. Okay, it's enough to have one side to find the remaining two sides. You don't need to have two sides. Okay, so how are we gonna find the remaining side? What's given? One side is given, not the hypotenuse, one side. Okay, this one's called hypotenuse, one of the sides or one of the legs. If this leg is 6, what can I say about the other one directly? Since it's a right isosceles triangle, so I have AB is equal to BC is equal to 6 centimeters. So now I have two sides. So now I have 6 and 6. So directly I can use what? Pythagoras, since we have what? Two sides are given. So then I will use Pythagoras, and then I will find the measure of the hypotenuse. AB squared plus BC squared equal to AC squared. Then I will replace, and then I will have what will be AC radical 72. It's similar like the exercise that we did in the worksheet. This is one case of a special right triangle. I can give you the hypotenuse and ask you to find the other two legs. So this is case 2, the hypotenuse is given. So here the hypotenuse is 5, and the question is to find BC and AB. How are we gonna find? If you look at the figure, you can see that I put those signs, it means those two are equal. It means those two sides are equal. So also, since ABC is a right isosceles triangle, so AB is equal to BC. I name it A because I don't know what is the measure, and I need to find AB and BC. Then I will write the formula of Pythagoras, AB squared plus B squared equal to AC squared. I will replace AB and BC by A. I name it A, you can name it X if you want. A squared plus A squared equal to 25. 2A squared is equal to 25. A squared is equal to 25 over 2. So what is the measure of? It's radical 25 over 2. Radical 25 is 5 over radical 2. Then I can rationalize by multiplying the numerator and the denominator by radical 2. You know this from last year, and you will see it in the next chapter. Now, you can stop here now if you want, but the next chapter, when I will start the rationalize, you need to do it. If I multiply numerator and denominator by radical 2, I will have radical 2 times radical 2, 2, and 5 times radical 2, it's 5 radical 2. Those are the two cases of right isosceles triangles. It's easy. If I want to generalize now, this is how to find it. But you can see in some books, they will give you a rule to memorize. I don't like to give you the rules, but as a teacher, I will give it to you. But Anna, I don't advise you to study the rule at all. Just do the method. We have those two cases. Or one side is given. I know that the other is the same, and then I find the hypotenuse. Or this case, like the hypotenuse is given, and you need to find the other two sides. This is the rule because if you saw it in any book, I don't want to say Miss Mira didn't give it to us. So it's a rule. In a right isosceles triangle, if those are x, the hypotenuse will be x radical 2. It means if this is 4, this is 4, this one will be 4 radical 2. If this is 5, this is 5, 5 radical 2. 7, 7, 7 radical 2. But I prefer to know how to do it, not to memorize the formula. Okay? I prefer, as an advice, don't memorize the formula. Okay, so in a 45, 45, 90 right triangle, the hypotenuse is radical 2 times as long as each leg. So if those are 4, هيدا 4 radical 2, 5, 5 radical 2. But if the hypotenuse is given, it's hard to find the side. That's why it's better to remember how we got it in the preceding part. Now let's go to the other one. You know what? I'm gonna stop here, and the semi-equilateral triangle, I prefer to do it in another video to make it easier for you. Okay, so I'm gonna stop here, and this one we're gonna do it in another video.